On question 4, you've got to draw a rectangle, first of all, and then you've got to draw the image after it's been transformed by the matrix. Now, in order to get a neat diagram, I have put it into autograph. There's the image, and the blue one's the original rectangle. The question is, how do we find where we're drawing it and where these vertices have gone? Obviously, that was 0, that was A, that was B, that was C. This is A dash, B dash, C dash, where those are the images of the points. Well, how can we work that out? Well, when you apply a matrix transformation to a point, we do the matrix times the coordinates of that point in matrix form, like this. You can't get it the wrong way around because you won't be able to multiply them, and if you do and you successfully multiply them, you've made your own rules up. Right, so the point 0, 0 goes to 0, 0. That's pretty common in our 2D matrices. 0, 0 is always invariant in the ones we do. We've got to do that to every point, but there is a quick way if you would like to do everything at once. So what we can do is we can put all these points into a matrix. So there's point 0, point A, point B, and point C, and now we can multiply the whole lot at once. If you need help with matrix multiplication, see the earlier questions. So 0, 0, so I'm just going to go to 0, 0. So then we've got 1, negative 3 times 3, 0 is going to give me 3 here. Root 3 times 3 plus 1 times 0, 3 root 3. 1 times 3. Okay, so that gives us the exact form, which is going to be useful later. In terms of drawing, you might just want to convert some of those to decimals, so you'll be able to draw them in approximately the right place. There we go, and then you can draw your coordinates, this being 0, this being the image of A, this being the image of B, and this being the images of C. For part B, it now wants us to describe the transformation. Now, if you've drawn a fairly accurate diagram, you should be able to work out that that's a combination of a stretch, or an enlargement rather, and a rotation. Alright, when we've got an enlargement, what we want to do first is work out the scale factor of the enlargement. So to do that, we're going to compare one edge of the triangle. For example, this one, so from O to A, that has 3 units, with the new one, which is 0 to A dashed. So what we've got to work out is how long is this how long is this line now? Now, the image of A is at 3 root 3. So if we want now the length of OA dash, we're just going to use Pythagoras on that. 3 squared plus 3 root 3 squared, square rooted, which gives us the answer of root 36 or 6. So the old line OA, the length of OA was 3, so you can see the scale factor is 2, as it's now twice as large. So what we then do is, using our exact form of our matrix, here was our transformation matrix, we take out the scale factor at the front. So the matrix is now 2, a half, negative 3 over 2, sorry, negative root 3 over 2, root 3 over 2, and a half if I take out scale factor 2. I can then see, we already worked out from the picture as a rotation. Here's the rotation matrix from the formula book. So we're going to match up. So we've got the half is cos theta, root 3 over 2 is sine theta, and if you solve that, it will tell us the angle is 60 degrees. So, describing our matrix, it is an enlargement scale factor 2 and an anti-clockwise rotation through 60 degrees about the origin.